Gentlemen, we're back again. Today we're tackling notes 1.3. How do you prove and use properties of midsegments of a triangle? Okay, so here we have one theorem we're going to talk about, the Triangle Midsegment Theorem. It states that the midsegment of a triangle is parallel to the side of the triangle and its length is half the length of that side. So basically what that's saying is I'm going to have some boxes on Google Slides, so please fill out these as I write them down. So D is a midpoint. So I want you to write midpoint in this box. Okay. E is also a midpoint. So again, there's going to be a box on this side. All right. The midsegment is just like it would sound. It's this area right here in the middle. It's this line in the middle, or this segment in the middle. And again, in that box, you're going to put midsegment. That's why we call it midsegment, because it's in the middle. Midsegment, middle. Okay? And then in this box, this is our parallel side. So this is what it was talking about. The midsegment of a triangle is parallel to the side of the triangle. So this is the parallel side. Okay? So a couple of notes you want to write is, you want to write in this box, you're going to write not congruent. The midsegment is not congruent to or equal to the parallel side. So this is not equal to this. Okay? So in this box, you're going to write 2 midsegment, or 2 times your midsegment, equals the parallel side. Okay, sorry, my writing's getting a little bunched up. Okay, so in this case, specifically, you're going to say 2 times DE, which is our midsegment, equals BC, which is our parallel side. Okay, so that's our parallel side, that's our midsegment. Now, you don't have to write the arrows, but basically I'm just saying that the midsegment is DE, and the parallel side is BC. Okay, so DE and then BC. Okay, now you don't have to draw these other little boxes and circles. I'm just trying to emphasize that. All right, so with that being said, we need to fill out these parts. All right, so let's start off with our first example. We have 1. It says segment JK, segment KL, and segment JL are midsegments of triangle XYZ. So here's X, Y, and Z. So that's our triangle. So basically what it's saying here is that the segments that they mentioned, which are, I'll circle them and or use different shapes. For JK, it's these 2 here. So this segment is this line right here is JK. Okay. I'm gonna erase it as I get done, so that way you can see it. Okay. The next one was KL. So I'm gonna use boxes for this one. So KL. So that's KL. So it's this segment here. Okay. And then lastly, we have JL. And I'll use like a little cloud, like a bubble or whatever, a little squiggly. Because that's JL. So this is the segment here, JL. Okay? So those are the 3 segments that are inside this triangle that function as midsegments. So we're going to take each one at a time. JL is parallel. So remember, JL is parallel. So if you want to, you could, if I draw it here, you can look and see what side is it parallel to. It's not parallel to this side because, again, parallel means that it keeps on going without touching. The only side that it's parallel to is XZ. Okay? So you see this side right here? Sorry. That's our parallel side because you look at it. They're parallel. If they kept on going, they would never touch each other. Okay, our next one is YZ. So this time, I forgot what it is. YZ. So YZ is here and here. So that's basically saying here. Now, in the previous problem, we went from the mid-segment to the parallel side. So you could also go in reverse. This time we're starting off with the big side or the parallel side, and we're talking about what mid-segment is parallel to it. So the only mid-segment of the ones we mentioned earlier is JK. Because you look at it, if you color in JK, you see that they're not going to ever touch. So JK, okay, so YZ is parallel to JK. All right? Does anybody have any questions? Erase that. So we can start over. Okay, our next one is KL. So we got KL. So I'm going to draw a box around K and a box around L. So that means that this is this segment. Well, the only parallel side that is parallel to it is this right here. And that's going to be XY. Okay? So XY. So that's line segment XY. All right? So you always want to look at, when you have a mid-segment, you want to look usually to the left or up or down or to the right and find the side that when you color it in or shade it in, it will be parallel. So you see that these two lines here would never touch. If they kept on going, they would never touch. These segments, if they were lines and you kept drawing them in either direction, they would never touch. And that's where the parallel line is. All right? So for the next section, I have to give you some information. All right? So this will be provided to you on your form, on your Google slide. Okay? So we know that the measurement of this, we're told that the measurement of XY, okay, is, let's hold off on that, sorry. I'm going to do it this way. We're told that XZ is 56. So XZ, so we find XZ, so XZ is here. So we're told that this whole line, this whole side is 56 units, okay? Not as for JL. Now JL is this segment right here, and that's our mid-segment, because remember, that's parallel to this segment. So we go back to our original theorem that said 2 times the mid-segment equals the parallel side. So what we're doing is we're going from the parallel side to the mid-segment. The simple way of doing this is saying 56 divided by 2. So 56 divided by 2 is 28. So JL is 28 units. So if you're going from the parallel side to the mid-segment, you divide. Remember that. So remember, going from parallel, we divide it here. Again, you don't have to write this, but I'm just going to write that there so you can have it there. Okay? So the next one we have is this segment here, which is KL. Okay? KL, we're told, is 32. So we find KL, so it's right here. And we're told it's 32. Not as for XY, which is this segment here. Now this time we're going from the mid-segment to the parallel side. So we're going from the small to the big. So remember, when we went from big to small, we divided. So we do the opposite when we're going from small to big. And that means we multiply. Okay? So here, what we're going to do is we're going to say 32 times 2. And that's going to be 64. So this is 64 units. Okay? So you remember when you're going from, and I'll write this on the on there for you to know, you're going from big to small, you divide. If you're going from small to big, you multiply. All right? So now, that was if we're dealing with numbers. But remember, we're not always going to be dealing with numbers. A lot of times we are going to have expressions with variables. All right? So for 6, you're going to need to keep this in mind. If YZ, so we got to find YZ, so it's this section right here. If this is 6x minus 20, and we know that jk is 2x plus 3, which is, this is jk, remember, then we need to find x. So remembering that jk is a midsegment for yz, because it's that's our parallel side, that's our midsegment. What you're going to do is you're going to say 2 times 2x plus 3 equals 6x minus 20. All right? So now, just like we did in regular algebra, we're going to distribute the 2 inside and get 4x plus 3 equals 6x minus 20. Okay? So now, I'm going to subtract 3 from both sides. Okay? And that gives me 4x. That cancels, leaving me 6x minus 23. Because negative 20 and negative 3 give me negative 23. Then I'm going to subtract 6x from both sides. Oh, sorry guys, Mr. Harper made a mistake. Sorry about that. So we got to kind of back up a second. Erase this. So again, I'm glad you won't have to worry about this. Remember, 2 times 3 is 6. All right, so we're going to still subtract 6 from both sides and get 4x equals 6x minus 26. We're going to subtract 6x from both sides and get negative 2x equals negative 26. Divide both sides by 2 and get x equals 13. Okay, so please show all your steps here, guys, so that way you'll remember how you got the answer. Okay. So for the next one, I'm going to reset. I'm going to erase everything I have on my triangle. And now this time we got KL, which is here. I'll highlight it. That's KL. We're told it's x plus 20. Okay, and then XY, which is over here, we're told it is 15x minus 10. Okay. So now we're going to say 2 times x plus 20 equals 15x minus 10. All right, because remember, 2 times our midsegment equals our parallel side. So we distribute 2 inside. This time Mr. Harper's going to do it right and get 2x plus 40 equals 15x minus 10. We're going to add 10 to both sides and get 2x plus 50 equals 15x. We're going to subtract 2x from both sides and get 50 equals 13x. We divide both sides by 13 and get x equals 3.8. Now we're not there because remember what the question asked. It didn't ask us to find x like it did over here. Here it tells us to find KL. So what you're going to do is you're going to plug in 3.8 where KL is. So remember KL, I'm going to do it over here, was x plus 20. So that means we're going to say 3.8 plus 20, and that's going to give us 23.8 units. That's KL. Okay, so guys, please, please, please remember to read the question and see what it's asking for. All right, so in our next video, we will work on some more example problems like this, and then you'll have some problems to do on your own. So I'll see you in the next one. Bye.